All right, let's start with some blue here. Medians, altitudes, and perpendicular bisectors. Let's get a little crazy here. We're going to start with a triangle. Will, what would you like to call that triangle? Triangle.
Oh, A, B, C.
Wow. Make it your initials, dude.
So, Will, I'm giving you full reign. You can name this triangle anything you want. Any 3 letters. You could use symbols. You could use Greek letters. I don't care what you do, and you choose ABC. Let's try that again. So we need a triangle. Will, what do you want to name that triangle?
ABB.
Be aware, there is no wrong answer. If you'd like to stay with ABC, we can work with ABC.
X, Y, Z.
Oh. You are a madman. I'm so glad I gave you the opportunity to change. All right, well, just because I'm feeling kind of crazy today, where would you like the point X to be? And well, hold on, let me give you a stipulation. Just because it's our first time doing this, I would ask that you keep integer values there. Don't give me like the square root of 3 comma pi. We'll save that for later. Where do you want X to be? Again, no wrong answer.
Just any number.
Whatever you'd like.
13.
13 is a good start. 13 comma. 13's lucky.
I thought 13 was unlucky.
Shh.
8.
8. Any particular reason you chose those 2 numbers?
No.
Awesome. Ashley, Will needs a break. Where would you like Y to be?
35.
And Brenna, you get Z. However, I would ask, just as a favor to me, if you could throw in at least 1 negative number. You could use 2, but at least 1. And the choice is yours. If you're only going to use 1, you could make the X negative or the Y negative.
Okay. -3, 7.
I like it. Okay. So we've randomly generated the triangle XYZ. We're going to calculate a couple things from this triangle. Hopefully, this works out and it's actually a triangle. We have had some freaky instances where the 3 points I was given turned out to be all on the same line and then everything falls apart. But we'll see what happens. I don't care what the triangle looks like, but I am going to draw a triangle as reference, just so I can see what's going on here, because I am a visual learner, so X, Y, and Z. We good so far? Awesome. I want to start by writing the equation of the median XA. Okay, and we'll use a different color. Let's go with red. We're looking for the median XA. And I'm going to turn it into a line, even though by definition a median was a segment. We're going to turn it into a line because we may have to find, we're going to be working with lines more so than segments. If you're still confused, let's take a break for a second and do a PSA. If you're still confused about some of these centers, if you haven't already looked at it, on the Schoology site, I put up a file called Center Summary. If you're still confused on what these things are, you might want to pull that out on your iPad now so you have it as a reference. If you're solid on what these things are, then don't worry about it. Or if you want it for reference later, it's there for you to check out. Okay? Ben, what's a median?
Median is a line segment that passes through a vertex in the midpoint.
Awesome. You'll notice, Ben, that in my diagram I don't have an A. Where do you think A would be? A would be. Yeah, A would be.
No.
Never mind. Where's A?
X.
No. X is X.
The midpoint of Y and not Z.
I like it. Well done. So I would like to write the equation of the line that passes through X and A. Again, as Ben read off for the definition, it's a line segment, but we're going to turn it into a line. I need two things for the equation of a line. What are they? Emmett?
Slope and y-intercept. Point.
Good. A slope and a point. Do we have either of those, Emmett?
You can find the midpoint, right?
Can I?
Well, like,
I can, yes.
well, if you
I'm
found
a trained professional.
where the midpoint is, you can.
Okay, so we could use the midpoint. Good. Any other options? No? Yes.
Yes.
No. 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 Yes.
X.
X?
Yeah.
X. What about X?
You can use that point.
We could use X.
Yeah.
Which one would you like to use?
X.
X, so then we don't have to find A?
I mean, that would just be more convenient.
It would be, because we already know where X is.
Yeah.
So we don't need to find A. Ben, why did we put A on there if we don't need to find A?
For the fun of it.
Just for the fun of it, okay, all right. All right, so we have the point. We're gonna use the point 13.8. Thank you, Will, by the way, for 13.8. Appreciate that. What's the slope?
Oh, so you,
What's that, Mary?
I don't know.
You do need to find A.
Wow, she has a revelation, then she just brings an attitude. I don't know. She had the right answer, and then she just like, I don't know. I know I was right, so what? Michael?
In order to find the slope of the line, you have to find A.
All right, so we do have to find A. How do I do that? Midpoint. So notice my notation. I'm going to find the midpoint of YZ, which I'm going to call A. Michael?
You do the midpoint formula.
Do tell.
Oh, isn't it like something
Sorry, just gonna do that all day.
Tried.
Only got 15 minutes. Molly, help me. How do I find the midpoint?
Isn't it like x1 minus x2 over y?
Oh my.
No, that's slope. We'll come back to you.
Oh, it's okay.
It's something
I
divided by
believe
2.
in you still. Oh.
It's something divided by 2.
Oh.
That's not wrong. Rebecca,
Whoa, did I just like make everyone think that?
go ahead.
Okay, so it's,
You didn't hurt yourself, did you?
no.
Did I just
Okay, go ahead.
Okay, so x1 plus x2
Oh.
divided by 2 and y1 plus y2
True.
divided by 2.
Awesome. So in this case, A would be where? Rebecca. So in this case, A would be where? What's x1, what's x2?
So x1 would be 3 and x2 would be -3. And then y1 would be 5 and y2 would be 7.
Well, that worked out nice. It won't always do that, by the way. You'll get some ugly numbers. Now, that's just the midpoint of YZ, which tells us where A is. And as our calculations get more and more complicated, you're going to want careful notation. Okay? So a picture where you're labeling. I don't want points to just appear out of nowhere. I need to know where A is or what A is. That's why this statement is here. Midpoint of YZ, we're going to call A, and it's located here. What's the next step? What other chunk of information am I missing, Morgan?
The slope.
Slope. So I'm going to calculate the slope. The slope of what? Well, little sub notation here. The slope of XA. How do I calculate slope, Morgan?
Just y2 minus y1 and then x2 minus x1.
Beautiful. Now, what are x1 and y1 and x2 and y2?
6 minus 8 or 0 minus 13.
Simplify your fractions. Negative over a negative is positive. Okay so far? We have the two necessary components. We have a point and we have a slope. And Emmett, you said we're going to use x?
Yes.
Okay, so therefore, Emmett, what would the equation of the line XA be?
Hold on. Y minus. Oh, y minus. Hold on. Oh, y minus 8 equals 2/13 in parentheses x minus 13.
How do you do?
Find x.
Okay. Now I just have an equation floating out there in the middle of nowhere. I would probably want to note that that is in fact the line XA. Just because I know where we're going eventually, one of the skills you're going to have to be able to do is to convert this into slope-intercept form. Remember on the quiz where we had the system where you both had them equal to y? This is not equal to y, so you need to be able to convert this to slope-intercept if you choose to solve equations that way. So just for giggles and for practice, let's convert this to slope-intercept form. Go ahead, you try. I'll work on my own. Don't look up here. Don't look up here, Mary.
Okay.
We ran into a weird situation here because it turns out that the midpoint of A, this is a complete fluke, happened to be the y-intercept.
Oh.
So I knew I got it right because I have it here, but I still did the math. Distribute the 2/13 to each of those, move the 8 to the other side, and I end up with that. Okay. So that's enough to get us where we need to go, but later on, we're going to be doing that. For now, you can just leave it in this form unless it specifically says to solve for y. Okay? That's a median. Any problems? We're good? Can I erase this before we move on? Good. Next on the agenda is an altitude. And we're going to look for the altitude. YQ. Vanessa, where's Q?
Would it be the
Hold on, let's back up before you answer that. Tell me what an altitude is.
a line through a vertex of a triangle perpendicular to the opposite side.
Good, so let me draw that. Now that should be easy. Where's Q? Yeah. This is Q. Not the midpoint, just some random point on XZ. And be aware of the fact that sometimes Q might not be even on the segment XZ, but we don't care. We just know that Q is over there somewhere. And we're going to make it that point of intersection. Okay, so now we repeat the process all over again. I need two things for the equation of a line, a point and a slope. Do I have either of those?
Yeah.
Yes? Paul?
You have a point.
I have a point. Which one?
One.
Y. So I know I'm going to use Y. So I'll make a note up here. Y is 3, 5. Thank you, Ashley. How do I find the slope, Grace? I'm actually going to do this whole calculation without finding out where Q is. Anybody else? How do I find the slope of y cubed? Kind of an awkward y, isn't it? I'm not giving you this one. You got to figure this out on your own. You already spoke.
Can I ask you a question?
Can you ask me a question?
Yeah.
You can always ask me a question. I just might not answer it.
Can you use XA?
I was going to give you a smart aleck answer, but I'll give you a legitimate answer. No, it doesn't do you any good. I was going to say, yeah, you could, but it won't do you any good. But then we do a bunch of work, and then it'd be like, psych, just kidding. Has nothing to do with XA.
Okay.
Nicole,
You can find the slope of xz and then take that and like take the opposite reciprocal of that slope and you can get yq because it's perpendicular to xz.
Are you breathing?
let's give it up for that one, huh?
Oh my god.
Nice.
Oh,
They're not clapping for you, by the way. They're just clapping for, thank God he didn't call me. Oh.
Oh my god, I would never guess that.
So we want the slope of xz. Okay, go ahead and do that. I'll wait till you give it a shot. Make sure you get the right answer. A little practice here. Oh.
Nice fractions.
All right, Nicole, since you started this mess, if the slope of xz is 1/16, then what's the slope of, not x cubed, y cubed? That would be yak quail.
The slope would be negative 16.
Negative 16 is correct. Flip it over, change the sign. Also known as an opposite reciprocal. We got everything we need, right? Okay, so the equation of yq would then be y minus 5 equals negative 16 times the quantity x minus 3. Well, that's fairly nice. Beats the ugly fractions we had in the last one. Okay, so converting to slope-intercept form, we would get negative 16x plus 16 times 3 is 48. So y is equal to negative 16x plus 53. Ooh, that is, this triangle would not be pretty if we graphed it. And a y-intercept of 53. The other one was 6, so way up there. Okay, hot diggity. Any problems on the altitude? Okie doke. Can I erase? All right. Last one, perpendicular bisector. Now you'll notice I've been purposely choosing different vertices to work with just so that the picture doesn't get cluttered. But if you were paying attention in the last couple lessons, you'll notice that there is no relationship then between that black line and that red line. They just happen to be coming from different vertices. So since we worked with that and we did that, let's do the perpendicular bisector of xy. And what color do I have left? I have green. Hopefully you can see this. Okay, so we want the perpendicular bisector of xy. And we'll call that, we won't call it anything. We'll just call it the perpendicular bisector of xy. Can you see the green? Is that okay?
Yeah.
Good. What do I need? Madeline, any ideas?
Well, a perpendicular bisector is a line that is both the bisector and is perpendicular to the side of the triangle.
Good.
Yes.
Excellent.
So you need a line.
I do. Shall I draw that line in?
Sure.
Okay. What do you want to call that point just for discussion purposes?
D.
D as in donkey.
Sure.
Okay. What can you, and again, just for discussion purposes, let's put a random point on the line, just so we can refer to it as line blah, blah, blah. What do you want to call that second point?
M.
M. Gee, I wonder why you chose M. Why the D, though?
I don't know.
Okay. So what can you tell me about the line MD?
That it has to be perpendicular, so it has to be 90 degrees.
Good. And?
And that it bisects the line XY. So
Wait.
it'd be the midpoint.
What's it?
D.
D is the midpoint. Okay, so you want to start with the point or you want to start with the slope?
Point.
Point. So we're going to find D. So we're looking for the midpoint of XY, which we have decided to call D. Madeline, where is D?
Would be y1 minus y2 divided by 2, so it'd be
Plus.
no plus 2. It'd be 8. It could be 13 plus negative 3 plus 3 divided by 2, and then 8 plus 7 divided by 2.
So D is at 8, comma 13 halves. Ooh. Leave it in fraction form. Don't convert to decimals. Even a fraction like this that is a nice decimal, 6.5, leave it in fraction form. Outstanding, we now know where D is. Next step, Madeline, how do I find the slope of MD?
You have to plug it in to you have to use the point, so it'd be like 8. I don't know.
Subash.
Use the line XY.
Yeah,
Find the slope of the line, then it's perpendicular to the.
beautiful. Slope of XY, which is 8 minus 5 over 13 minus 3, which is 3 over 10, so 3/10. Okay, so therefore the slope of MD would be what? Anybody? Negative 10/3. I have a point, D, I have a slope, so that Gesundheit, so then I can find the equation of the line MD, and that would be y minus 13 halves equals negative 10/3 times the quantity x minus 8. Hey,
Fun.
just for giggles, let's convert that to slope-intercept form.
I'm good.
Well, you can say you're good, but you won't be. And that's why you have your calculators. Let's see. Since you're not using this, may I?
Sure.
I thank you. 80 divided by tree, enter. plus 6.5, enter, math, enter, enter. I can't even read that. What's that say?
199/6.
I just threw up a little bit in my mouth. Wow. No, I don't even want to touch that anymore. Ugh. You need to be able to do that, by the way. Shall I review that?
No.
No? You're good? You can do that?
Yeah.
Okay, awesome. Are we good? That's all three possibilities. One thing you'll notice we haven't talked about is in-centers. We're not going to do this algebra stuff with in-centers. So suppose I have a different triangle here. We'll call this triangle DOG. If I wanted to find, based on what we've just done, if I wanted to find the circumcenter of that triangle algebraically, how would I do it? Emmett? Just stretching, doing some yoga? Desk yoga? Nothing? Okay. Oh, Vanessa.
Well, circumcenter is the point of congruency between perpendicular bisectors of a triangle.
Right. Concurrency though, not congruency, but
Yeah.
point of concurrency between the perpendicular bisectors of a triangle. So again, I would ask the question, how would you find it then?
Draw the lines.
That's how I would draw it. How would I find it algebraically?
First find the perpendicular bisector for all the vertices, and then connect them.
Oh, connect them. I'm a little iffy on that whole connecting part, but we'll get to that later. Okay, so we're gonna crawl before we walk here, and then we're gonna walk before we run. So you should be able to come up with the medians, the altitudes, and the perpendicular bisectors of a triangle, and then we'll build on that as time goes on. Okay, we good? Awesome. I don't even know what day we're on. 6?
I thought it was 4 or 5.
Day number 5.
Can we change